Okay, so in this video I want to cover the closed form of an expression like this, and this may show up in certain finance problems. As an example, let's say you are given a certain rate of return on a bank account, right? So you start with a certain amount here, and then the next year you may have 5% increase, and then it's going to compound, right? And so let's ask if we can put this in a closed form. And the thing you may notice is that if I multiply this series by r, then I'm just going to get a naught times r plus a naught times r squared, and then all the way up to a naught times rn plus a naught times r n plus 1 because of this term here. Now the question is, can we get s in some sort of a closed form? That way we don't have to keep adding terms, right? Because this may go on, not forever, but it may go on for a long time, especially in finance. Let's say you have a 30-year or something portfolio. Well, now I've got a bunch of terms I've got to add, right? I'd rather not do that. So if you notice, if I subtract s from rs here, so let's do rs minus s in this case. Notice that my a naught term is going to, normally how it's done in books is we do s minus rs. I've never really liked that, but I'm going to be consistent with how you're probably taught. And so in this case, we're going to have a naught, right? Because there's no a naught term by itself here. But then notice this term cancels this term cancels this term. In fact, it goes on all the way up until we get to this term. So now I have minus a naught rn plus 1. Well, notice what I can do here. I can factor out this s, and this becomes s times 1 minus r is equal to a naught times 1 minus r raised to the n plus 1. And now I can just solve for this s directly. As a naught times 1 minus n plus 1 over 1 minus r. And so notice that the only concern we have with evaluating this function is with the beginning point of this function and the end point of this function. Now, of course, r cannot be equal to 1 in this case, but this is how you would form the geometric series of this function.